Hello again. Now that we know how to implement conditionals and loops in assembly, let's see how we implement a little more complex control structure here. We're going to talk about switch statements. And the way switch statements work in C is as follows. Here I have an example here. If I say switch X, now what I'm saying is that now there'll be a bunch of options that depending on the value of X, I'm going to execute a different piece of code. Okay? So here in our example, if X happens to be set to 1, I'm going to execute this piece of code here. And then this break statement just says that this piece of code is going to be executed, and then we're going to stop and continue executing past the end of the switch statement. There's some other cases called fall-through cases that do not have a break statement. For example, if X happens to be set to 2, this piece of code is going to be executed and it's going to continue executing through the next block until it sees the next break statement. Then this goes, jumps it out of the switch and continues executing. Okay? And also, if you have any missing value in a set of cases, for example, if X happens to be set to 4, since there's no case for 4 here, what gets executed is the default value. So it's the default block of code. So the way to think about the default is that the value that you're switching on is not in any of the cases, you execute the default case. And why you could implement this with branch instructions that we saw earlier, it gets really complicated quickly. So another way of implementing this is using what we call a jump table. And a jump table works as follows. Say here we have our example, we have an example of a switch statement. Now we're going to have a table that has roughly as many entries as the number of cases in our switch statement. The number of cases in our switch statement. Okay? And now in each one of these entries in the table points to the address of a code block, which is corresponds to the code block that has to be executed based on the case value. So for example, if our X happens to be val 1, we're going to look at the jump table, get the corresponding address, and select the start one, and that's the code we're going to execute. We're going to execute this piece of code here. Now, one way to think about this is the following. You could have a variable called target, which holds the target address for a given option. We're going to look up our jump table, which is just an array of instruction addresses. We're going to index that array with X, and we're going to get the value starting target, and we're going to jump on it. We're going to do a go to and use that as an instruction address and go to and do a jump to that address, go to that address. So here's another way of looking at this more visually. I have another switch statement, and for each one of the cases, I have the corresponding region of memory, just do the color matching there. And then our jump table is going to map back to the corresponding memory region that implements that block of code corresponding to the case statement. So now 1 is green, so that means that the entry 1 here has to point to green. That's this 1. And same thing for orange, and so on. Okay. Now note there's an interesting case here, which is the default case. The default case, as I said before, gets executed if the value of X happens to be none of the values explicitly defined by cases. Okay. So here, if it happens to be 0, right, we're going to jump to the default case. It also happens to be 4. We're going to jump to the default case. Okay. And we can use a jump table as long as the value is lower than 6. For any other value that's greater than 6, we're going to execute the default code, the default block. Now this jump table is just a list of addresses, and here's how it gets set up. In assembly, you'd see a declaration of a long word that happens to be the same value as the label that maps to the address of the code block. Okay? So now this, for example, if we take .L61, and that's where the default code block starts, so the corresponding instruction address is going to be stored here, and same thing for the other case values. So let's see how we use this table in assembly now. So here we have the jump table, and what we're going to do is we're going to, depending on the value of x, which is loaded in edx here, we're going to find the corresponding entry. And the way this is done using a indirect jump. The indirect jump says that instead of jumping to a specific address, it jumps to an address contained in an address. So the way this is working is this .L62 here is the base address of our jump table. Now the value of edx gets multiplied by 4 and added to that. So it's multiplied by 4 because a long word is 4 bytes. So if edx is, say, 4, we're going to add 0. We're going to add 4, 1, 2, 3, 4, and that's the value that's going to be jumped to. Okay? So another thing to note here is that we are comparing whether x happens to be greater than 6. And if it is greater than 6, it jumps straight to default. Okay? So now let's see how the code blocks are implemented. So here, suppose that we have, we're interested in case 2 here. And case 2 happens to be mapped to label.L57. That means that this is where the assembly code that implements the block for case 2 is located. So we have a division here, so that's why we must have a division instruction here. And note that this is a fall-through case, so it's going to be, in case x is 2, it's going to be executing, and it's going to continue executing through the next case block here until the break statement. And the break statement here is implemented by essentially just finishing the execution, returning from the function in which the switch block is inserted. Okay? And note here that the default case also, after this, there is a return. So if you look at here in label.L61, we're going to see here that right after being done with the corresponding code block, we also leave and return from the function. Okay? So here's the rest of the code block for our example. Again, you see the important thing to notice here is that you have returns after every single block that had breaks. And for both case 5 and case 6, they're both mapped to .L60, which is that label here. So let's see how these labels are defined now. If you look at the object code, you see that they become an instruction address, like I mentioned before, that's chosen by the linker. Okay? And there'll be one of those for each one of the case values in our switch statement. So if you go look at the entire table, you see that there will be one address per case statement. And those have to, as we saw before, point at a code block. So now we can look at each one of those, you see, map to a block of code corresponding to the code inserted in the case block for that value. So here's our list of instruction addresses for the jump table, and each one of them points to a block of code. And note that we have some repeated ones. Remember, some of the cases that had, for example, fall through, or cases that are not defined. So in this case here, it's the default value. For value 4, if you remember, it has to go through to the default case, so it points there. And the same thing for value 0. Now let me ask you a question. Would you implement this one with a jump table? Well, look at the size of this value here. Probably not. This table will be very, very, very large. Okay, so jump tables are used normally when you have few case values and you can build a small table for it. In this case here, it will be much more efficient to just implement this with branch instructions. So now we conclude our x86 assembly programming section, and I'll see you next time.